In this video, you will learn how to use the Universal PPS Analyzer tool. As the first step, connect all the PPS inputs. The PPS input reference is connected to our reference signal, which will be used to synchronize the PPS analyzer. The test devices can then be connected to the other PPS input BNC connectors. Of course, you can also connect them later to the running device. Now, power the PPS analyzer by connecting the micro USB cable. The LEDs of the inputs will indicate the incoming pulses. The PPS output reference LED will start blinking as soon the device has booted. The device will start synchronizing to the input reference. After a few seconds, the PPS output reference will be synchronous with the PPS input reference on the rising edge. The PPS output reference can be used to cascade multiple PPS analyzer devices. Let's start the Universal PPS Analyzer tool to apply some basic configurations. The PPS Analyzer supports UART or Ethernet for connection with the tool. Via Ethernet, you can also use the tool on multiple devices within a local network. In this video, UART communication is used, so let's open the correct port. A PPS tab is opening. The channels where a pulse is detected are indicated by a color. The inputs where no pulse is detected are grayed out. Now, the configuration can be adapted. The configuration is assigned to the Open COM port. The name of each PPS input can be set individually to better identify the attached device. The unused PPS channels can be deactivated. By clicking on Change Delays and Names, the new names are applied. The default view of the Universal PPS Analyzer is the offset chart, but the offset can also be visualized in a histogram. As the last configuration step, fixed delays, such as cable delays, can be compensated. Click again on Change Configuration. The value in nanoseconds to compensate can be added for each device. By clicking on Change Delays and Names, the delays are applied. In the offset chart, it will be visible as a jump. By clicking on the Clear button, the view is reset. Let's dive now into the different functionalities of the Universal PPS Analyzer tool. The offset chart view is a sliding window. With the scroll bar at the bottom, you can slide to earlier offset samples. The minus button allows you to zoom out up to a maximum of the last 100,000 samples. The plus button allows you to zoom in down to a minimum of the last 100 samples. The offset axis is, by default, auto-scaling with a minimum range of plus or minus 100 nanoseconds. Auto-scaling ensures that all offsets will be within the window at the required scale. By setting the tick on Fixed Scale, a manual scale can be defined. This allows you to set a fixed scale for a certain range. Offsets outside the manually defined range will not be shown. On the left side of the Universal PPS Analyzer, you'll find helpful statistical information for each PPS channel. This includes the current offset, the average offset, standard deviation, as well as the minimum and maximum offset. The statistics window always represents the current chart view, so the information depends on the zoom level. Zooming out includes more data in the statistical calculations. Zooming in does the opposite and reduces the amount of data considered in the statistics window. The Universal PPS Analyzer also supports thresholds that can be set for each input channel individually. If the inputs are below or above a threshold, this is also indicated on the pins of the PPS Analyzer shield. Let's set the thresholds to some values to demonstrate the threshold functionality. We set them close to the current offset value. By enabling the thresholds for the 3 channels and clicking on Change Thresholds, the thresholds are activated. The green tick indicates that the offsets are within the defined thresholds. When the red cross is active, it means one of the thresholds has been violated. Another feature of the tool is the ability to directly save the current view as an image. By clicking on Save View, you can choose a location to store the measurement as an image. It will save the offset chart and offset histogram as a PNG image with the current zoom level. Here is the offset chart image and the histogram chart image. Long-term measurements can be done using the log functionality. By clicking on Start Log, you can select the location where a CSV file will be stored. The button will change to Stop Log. The measurement duration is only limited by the available storage. Now, we stop the logging by clicking on Stop Log and confirming that we really want to stop it. Let's open the CSV file from the previously selected storage location. The file contains the timestamps and offsets of all enabled input PPS measurements. Exceeded thresholds will also be shown in this log file. By selecting the desired columns, we can easily create a chart to visualize the offsets. The Universal PPS Analyzer allows to calculate the Allan Deviation. Since the calculation can consume some computing power, it is not activated by default. In the configuration, the calculation can be enabled. A new tab, Offset Variance, appears. Both manual and auto calculation options are available. Auto calculation attempts to calculate the variance every second, but it also depends on the calculation time for the number of samples, which is shown. The calculation is performed over the number of samples within your desired zoom level, so the current view is always used in the calculation. With a zoom level set to the last 1,000 samples, the Allan Deviation calculation is done over the same amount. Not only the reference input can be used as the reference for the PPS Analyzer, all other PPS inputs can also be used as the reference. The reference can be switched in the configuration. Let's now select PPS Input 2 as the reference. By clicking on Change Reference, a warning will be shown. Changing the reference affects all Universal PPS Analyzer applications connected to the PPS Analyzer, such as those over Ethernet. In the offset chart, you can see that device 2 has become the new reference and now represents the 0 line. The offset measurements of the other inputs are now done relative to the new reference. In the final step, we will show how to change the IP address when using Ethernet as the connection. Go to the Advanced tab and click on Calibrate. The PPS tab will then change to a Calibrate tab. Be careful with what you click here. Do not click on Calibrate, as this can clear the calibration of the PPS Analyzer shield, which can only be restored with a calibration shield. Your device was calibrated before delivery. Now you can click on Read MAC and IP to get the stored MAC and IP address from the EEPROM. Change the IP address according to your needs and click on Write MAC and IP. The settings will now be stored in the EEPROM. Power cycle the device to ensure the changes are applied. More details you can also find in the reference manual of the PPS Analyzer. Thank you for watching, and have fun testing all the features of your PPS Analyzer.